Imagine holding a single grain of sand between your fingers. Now imagine that grain of sand contains more empty space than the entire observable universe contains matter. That's not a metaphor. That's not a thought experiment. That is the literal structure of the atom. And the more physicists look inside it, the more it stops resembling anything we understand about reality at all. For centuries, we thought the atom was the smallest thing, indivisible, a tiny solid sphere at the bottom of everything. Then we looked closer. And what we found wasn't a solid point at the base of reality. What we found was almost nothing. If you took a hydrogen atom and scaled it up to the size of a cathedral, the nucleus at its center would be the size of a marble. One marble, floating in the middle of a cathedral, and the electron, the one particle orbiting it, would be somewhere in the walls, too small to see. That's what you're made of. That's what everything is made of. Structures that are, by volume, 99.9999999% empty space. But here's what took physicists decades to admit. It isn't really emptiness. The void inside an atom isn't blank or dormant. It is filled with something. And what it's filled with is the most disturbing part. When Rutherford fired particles at a sheet of gold in 1909, he expected them to pass straight through. The atom was thought to be a diffuse cloud. The particles should have barely noticed it was there. Most of them did pass through, but some bounced back. Rutherford later said it was like firing artillery shells at tissue paper and having them return and hit you. That moment, a particle ricocheting out of apparent emptiness, shattered the model of the atom we had built. And it started a chain of discoveries that has never really stopped. What Rutherford had found was the nucleus, a tiny, almost impossibly dense point at the atom's center. Dense doesn't begin to cover it. A teaspoon of nuclear material would weigh approximately 1 billion tons. 1 billion tons in a teaspoon. But the nucleus is only the beginning of the strangeness. Inside the nucleus are protons and neutrons, and inside them, the story fractures entirely. Inside protons are quarks, particles so fundamental they carry no internal structure we've ever been able to detect. They have electric charge. They have spin. They respond to forces. But they cannot exist alone, ever. A quark in isolation is something the universe does not appear to allow. The moment you try to separate two quarks, the energy you inject is enough to create two new quarks to replace the gap. Reality refuses to let you reach the bottom, and quarks aren't the strangest residents of this inner space. Surrounding every atom is a quantum field, and this field is never still. Even in a perfect vacuum, zero matter, zero radiation, absolute cold, the field fluctuates. Particles appear and vanish in intervals so short they barely register on any clock we can build. Virtual particles, here for a moment, gone before they can be directly observed, but real enough to exert measurable force on the atoms around them. The void inside an atom is not empty. It's buzzing. Here is where the atom stops obeying the world you live in. At the scale of atoms, the laws of classical physics, the same laws that govern planets, pendulums, and every machine humans have ever built, simply stop working. Down here, different rules apply. An electron does not orbit the nucleus the way Earth orbits the sun. It doesn't have a precise location at all. It exists as a probability cloud, a smear of possible positions that only resolves into a specific point when you measure it. Before measurement, it is genuinely, mathematically everywhere at once.
This is not an instrument limitation. It's not that our tools are too crude to pin it down. The electron has no definite position. The universe hasn't decided yet.
This is what physicists call quantum superposition. And we didn't dream it up. We tested it. Repeatedly, rigorously. It holds. The atom is a structure in which the components, the very building blocks of matter, are not real in the way you are real right now. They're probabilistic. And the deeper you go, the stranger this gets. Two particles can become entangled. When they do, measuring one instantly determines the state of the other, no matter how far apart they are. Einstein called this spooky action at a distance. He was sure it couldn't be right. He spent years trying to find a way around it. He couldn't. We have now confirmed quantum entanglement in labs thousands of kilometers apart. The correlation between the two particles is faster than any signal, faster than light, and does not degrade with distance in any way we have measured. Information, or something that functions like information, moves between two particles across any distance in no time at all. We don't know how. We don't know what carries it. The equations describe the outcome perfectly. They do not explain the mechanism. Now consider this. Every atom in your body has a history. Atoms forged in stellar cores, passed through supernovae, cycled through oceans and organisms before arriving inside you. Some of them may carry entangled relationships with particles on the other side of the galaxy. The atom is not just strange inside. It connects the matter in your body to the rest of the universe in ways that violate our most basic intuitions about space and time. We've known for decades that the vacuum of space is not truly empty, but the vacuum inside an atom is even stranger. Quantum field theory describes every fundamental particle, every electron, every quark, every photon, not as a tiny ball, but as a ripple in an underlying field. Electron field, the quark field, the electromagnetic field. These fields exist everywhere. They permeate all of space, including the space inside every atom. And they are never at rest. At the quantum level, these fields fluctuate constantly. Energy appears and disappears in pairs, a particle and its antiparticle born from nothing, annihilating each other too fast to directly observe. They are called virtual particles, and though they exist for immeasurably brief moments, their collective effect is measurable. We can detect the physical force they exert on real particles right next to them. The Casimir effect, two metal plates brought close enough together that the vacuum fluctuations between them are suppressed, causes those plates to attract, with no physical substance between them, pulled together by the energy of apparent emptiness. The nothing inside an atom pushes and pulls. It has structure. It has energy. And according to the best models of cosmology we have, the vacuum energy of quantum fields may be the same energy responsible for the accelerating expansion of the entire universe. The void inside an atom, and the expansion of everything, the same phenomenon. Now we go deeper. Below quarks, current physics runs out of language. The Planck length, 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 have. At that scale, space itself is thought to lose its smooth, continuous character. It may become discrete, pixelated, a fabric with a minimum resolution below which the concept of between stops meaning anything. And here, at this limit, physicists have proposed something that makes the quantum atom look simple. String theory suggests that the most fundamental objects aren't points at all. They are one-dimensional filaments, strings, vibrating at different frequencies. The frequency of vibration determines what particle you get. An electron is a string vibrating one way. A quark is a string vibrating another. And the space these strings vibrate through? Some models require 10 or 11 dimensions to remain mathematically consistent. 10 dimensions, curled up inside the structure of an atom too small to see. We have not confirmed any of this. We don't yet have an instrument sensitive enough to test it. But the mathematics demands the possibility, and that mathematics has never, in the history of physics, pointed nowhere. Tone, spare, stark, maximum gravity, lands at approximately 74% within the required window. Here is the part that physicists don't dwell on in public. You are made of atoms. Every atom in your body is 99.9999999% empty space. The part that isn't empty, the nucleus, the quarks, does not consist of solid matter. It consists of energy bound by force. There is no hard, solid thing at the base of you. No bedrock, just fields, just forces, just the relationships between particles that themselves have no size, no interior, no surface. You are not solid. You are a pattern of forces in a field that learned to organize itself, to metabolize, to think, to look at the sky and ask questions. The rock you stand on is not solid. The chair beneath you is not solid. Two atoms never actually touch. Their electron clouds repel each other long before contact is made. The sense of solidity you experience every moment of your life is a consequence of electromagnetic repulsion between atoms that never reach each other. Nothing in the universe has ever touched anything else. Everything you have ever held was held at a distance. The atom was supposed to be the answer. The smallest thing. The final floor. The point at which you could stop asking what this is made of and simply say, this. Instead, it opened into rooms, each room into corridors, each corridor into darkness we are still walking through. What the atom tells us is this: reality, at its most fundamental level, is not made of things. It is made of possibilities, of probabilities that collapse into facts only when something or someone looks. The universe inside the atom does not obey our world. It is older than our world, and it will remain stranger than we are capable of imagining, at least for the foreseeable future. If this made you see the world around you slightly differently, I'd really appreciate a like or a subscribe. It genuinely helps this channel reach more people. Thanks for watching.